Hello viewers. In today's session, we are going to discuss two important problems related to the derivative property of Dirac Delta function, right? So before solving the problems, let us first quickly see the derivative property of Dirac Delta function. So now consider the nth derivative of Dirac delta function, that is the delta n x minus a, right? So here this n denotes the order of the derivative, and let us consider a test function, say f of x, right? So if we integrate from minus infinity to infinity, then the value of this integral may be given as minus 1 raised to n, and then we find out the nth derivative of this function, that is f of x, evaluated at this point, that is a, right? So we can write the nth derivative of f of x evaluated at this point a, right? So the value of this integral is given by this expression. So this expression is known as the derivative property of the Dirac delta function. So here we have the nth derivative of delta function, and when we have a test function f of x associated with the delta function, then the value of this integral is given by minus 1 raised to n, the nth derivative of f evaluated at x is equal to a, right? And obviously we know that the delta function is not equal to 0 at this point, but the delta function is 0 at all other points except x is equal to a, right? So we'll get the peak at x is equal to a. So we can also write this integral, that is minus infinity to infinity f of x delta of x minus a dx is equal to f of a, right? So now based on this derivative property, let us solve two important problems. So now consider this problem in which we have to evaluate this integral from minus infinity to infinity. We have t cube plus t square plus t plus 2, and the second derivative of delta function, that is delta t minus 1 dt, right? So let us call this integral as I, and let us rewrite this integral as minus infinity to infinity. We can take this function as f of t, and here this notation, that is d2 over dt2, can be written as delta double prime, and we have t minus 1 dt, right? So our function f of t is given by t cube plus t square plus t plus 2, right? And here the second derivative of delta function is involved, so here this n is equal to 2, right? And it is important to note that here the variable is t and here the variable was x, right? So the variable is not going to make any difference, and here the value of a is given by 1. So now the value of this integral due to this property is given by minus 1 raised to 2, because the value of n is 2, and then we have f of 2, and here we have a is given by 1, right? So this notation is it can also be written as f double prime of 1, right? So we have to find the second derivative of f of t. So we have f prime of t is given by d by dt of t cube plus t square plus t plus 2, right? So this is 3t square plus 2t plus 1. The derivative of 2 is 0. So now let us obtain the second derivative of f of t. So f double prime t is given by the derivative of 3t square plus 2t plus 1. So here we have 6t, and here we have simply 2, right? And the derivative of 1 is 0, being a constant. So the second derivative is given by 6t plus 2. So the value of f double prime at this point, that is 1, a is equal to 1, is given by replacing t by 1. So we have 6 times 1 plus 2. So this is 6 plus 2, that is 8, right? So here we have minus 1 square is plus 1, and f 2 of 1 can be written as f double prime of 1, and we have here simply f double prime of 1. F double prime of 1 is equal to 8, right? So the value of this integral is equal to 8. So now consider the second problem. So here we have the integral minus 3 to 0 log of natural log of t plus 3, and here the third derivative of delta function is involved. So we have the third derivative of delta of t plus 2 dt, right? So let us call this integral as I, right? And here we can see that the value of a is given by minus 2, because when we take t plus 2 is equal to 0, we get t is equal to minus 2, right? So the value of a is minus 2, and this minus 2, it belongs to this interval, that is the limits, and we can write minus 3 to 0, right? So minus 2 belongs to this interval minus 3 comma 0, right? And if we compare this integral with this one, then the value of f of t is given by a log of t plus 3, and the third derivative is involved. So we have n is equal to 3, because n denotes the order of the derivative. So now let us find out the third derivative of f of t, right? Because here we have fn of a. So the first derivative is given by f prime of t, which is d by dt of log of t plus 3, right? And the derivative of log of t plus 3 is 1 over t plus 3. So this is the first derivative, right? The second derivative is obtained by differentiating 1 over t plus 3 with respect to t. So we can write 1 over t plus 3 as t plus 3 raised to minus 1. So we have d by dt of t plus 3 raised to minus 1. So this is minus 1 t plus 3 raised to minus 1 using the power rule, and then by chain rule the derivative of t plus 3 is 1 plus 0, right? So we have minus 1 divided by t plus 3 raised to the power 2, right? So we can also write this expression as minus t plus 3 raised to minus 2, right? So this is the second derivative. So now let us find out the third derivative. So we can write this expression as minus t plus 3 raised to minus 2. So the third derivative f triple prime t is given by d by dt of negative of t plus 3 raised to minus 2, right? So again, applying the chain rule and the power rule. So here we have minus 1, this is minus 1, then we have minus 2 t plus 3 raised to minus 2 minus 1, and by chain rule the derivative of t plus 3 is 1 plus 0. So this is minus minus plus. So we have 2t plus 3 raised to minus 3. So this is 2 over t plus 3 raised to 3, right? So this is the third derivative of f of t, right? So now the value of this integral I is equal to minus 1 raised to n is 3, and then we have the third derivative of f of t evaluated at this point, that is minus 2. So now minus 1 raised to 3 is minus 1, and the third derivative of f of t at this point minus 2 can be obtained by taking t is equal to minus 2 in this expression. So we have 2 over minus 2 plus 3 raised to 3. So this is minus 1 times 2 is minus 2, and this is 3 minus 1 raised to 3. So we have minus 2 over 1, that is minus 2, right? So the value of this integral is given by minus 2. Hello viewers, in today's session we are going to discuss another important problem from Dirac Delta function. So here we have to find out the value of this integral involving the delta function. So we have the integral from minus pi to pi t raised to 4 and delta of t square minus 2 dt, right? So here we'll solve this integral with the help of one important property of Dirac delta function, right? So let us first will state the property, and then we'll see how we can apply that property to simplify this integral. So let us start. So let us first call this integral as I, and we can write this integral as minus pi to pi, and here we have t raised to 4, and here we can write this delta function as t square minus is the square root of the square root of 2, right? So here we have used this fact that 2 is equal to the square of under root of 2, right? So expressing t square minus 2 like this, because we are going to use this important property of delta function, which says that delta of x square minus a square is given by 1 over 2 times the absolute value of a, and then here we have delta of x minus a plus delta of x plus a, right? So this is the property which we are going to use to solve this integral. So now let us apply this property to this delta function. So we have here integral from minus pi to pi, then t raised to 4, and delta of t square minus root 2 square can be written with the help of this expression. So if we compare these two expressions, then the value of a is the square root of 2, right? So now this delta function is equal to 1 over 2 times the absolute value of square root of 2, and then we have delta of x minus a. So here the variable is t, so we can write t minus a. A is square root of 2, then we have delta of t plus square root of 2, right? And here we have dt. So now the absolute value of square root of 2 is simply square root of 2. So we can take 1 over 2 times square root of 2 outside the integral, and we have minus pi to pi t raised to 4, and this expression, that is delta t minus square root of 2 and delta t plus square root of 2, and here we have dt, right? So now let us write this expression or this integral as a sum of two integrals. So now we can write 1 over 2 times square root of 2. So the first integral is from minus pi to pi t raised to 4 delta of t minus square root of 2. Right, here we have dt, and then the second integral is from minus pi to pi t raised to 4, and here we have delta of t plus square root of 2, and here we have dt. So now we have two integrals involving the delta function. So to evaluate these two integrals, we'll make use of this definition of delta function, that is integral minus infinity to infinity. We have f of x delta of x minus a dx, right? So whenever we have a function f of x associated with the delta function, then the value of this integral is equal to the value of the function f of x at this point, that is x is equal to a, right? Because the delta function is 0 everywhere except at this point x is equal to a. So here we have f of a. Now here the limits of integration or the bounds are given by a minus pi and pi. Here also we have minus pi and pi, right? And here we have t minus square root of 2. So here the value of this a is square root of 2, that is approximately 1.414, right? And here the value of a is given by negative square root of 2, right? And this is minus 1.414, and we can easily see that these two numbers, that is square root of 2 and minus square root of 2, they fall within these bounds, that is minus pi and pi, right? So if we draw the number line like this, here we have 0, and here we have say minus pi, and here we have plus pi. The approximate value of pi is 3.14, so this is minus pi, here we have plus 3.14, and 1.414 it lies somewhere here. So here we have square root of 2, and here we have minus square root of 2, right? So we can write that square root of 2 and minus square root of 2 both belongs to this interval, that is minus pi to pi. So the value of this integral is equal to the value of this function t raised to 4 at this point. And similarly, the value of this integral is given by the value of this function t raised to 4 at this point, that is minus square root of 2, due to this definition, because here at this point x is equal to a lies within these two bounds, right? So here we may have different limits instead of minus infinity to infinity, right? So now the value of this entire expression can be written as 1 over 2 root 2, and here the value of this integral is root 2 raised to 4, and then here we have minus root 2 raised to 4, right? So we have 1 over 2 times square root of 2, and the fourth power of square root of 2 is equal to 4, right? And here also we have 4, so this is 8 over 2 times square root of 2. So this is 2 times 4, so we have 4 over square root of 2, and rationalizing the numerator and denominator, we have 4 root 2 over 2, so this is 2 times square root of 2, right? So viewers, the value of this integral is given by 2 times square root of 2.